today's session of network analysis. Today we are going to tell about the definition and terminology of solution of first and second order networks. Myself, Dr. Sayanti Chatterjee, Associate Professor of Electrical and Electronics Engineering in Institute of Aeronautical Engineering, Hyderabad. So today my first topic is about the solution of first order and second order networks. So what is the course objective? For this topic, the students will understand the three-phase systems of star delta. Especially for my today's lecture, the basic things is the present the necessary mathematical background and the transient analysis of DC and AC circuits, and study the transient using the differential equation and Laplace transform for the series and parallel circuits. So today my total lecture is based on the mathematical background and especially the Laplace transform. And what is the outcome? So the course outcome from this subject is the students will try to learn about the concept of initial conditions of an RLC circuits to determine the transient response of the first and second order system using the differential equation approach and the Laplace transform approach. In this chapter, we will discuss two approaches. One is the Laplace transform approach, another one is the differential equation approach. So, we are coming to our question number 5. Question number 1. What is the transient state? So, if we are going to define we are giving the definition, transient response can be referred as the system's instant behavior against the input change or disturbance. What does it mean? What does it means, say we have a pen. So, when the pen is in the fixed condition, we can tell it is in the one steady state condition. Now, if we give a simple little force, what is the force? Force we can think about the input. So, what will happen? It will go some forward, again come back, and again it will be at the fixed condition. So, this is called the transient. The transient response can be referred as the system's instant behavior against the input change or disturbance. So, I am giving one more example. Say we have a fan. We suddenly switched off the fan. What will happen? We are just discontinuing the switch off. So, the fan will not stop immediately. It will take, due to its moment of inertia, it will rotate for some time and slowly it will stop. So, this condition is called the transient condition. So, what is the transient condition? If we look into the triply or electrical view, so say we have a circuit like this and we have one switch. So this is our R, this is our L, and this is our capacitance C. So when we are, so it is a pure, if we are giving the pure sinusoidal output from here, now suddenly the switch is closed. Now if we are suddenly switch on or we will close the switch, what will happen? It will come down and slowly it will stop. It will make 0. So first condition, switch is off. Second condition, switch will open. First condition, switch is closed. Second condition, switch is open. So what will happen? It will follow some transient. And then it will be stopped. So this portion is known as the transient portion. Or we can think there is a constant voltage is going to an RLC circuit. Suddenly one voltage surge came. What will happen? Again it will show some transient behavior. It will go up, then go down, then go up, then go down, and ultimately it will be in the steady state condition. So transient response can be referred to the system's instant behavior against the input change, on to off, not input change. It has an input, we are suddenly cutting the input. Switch is closed, suddenly we opened the switch. Or disturbance, as I told, say we are giving the force and it is going front and back and front and back and ultimately it is stopped. So what is the disturbance? Disturbance is friction. What is the disturbance of this? The disturbance is friction. So this is called the transient state of any transient response. Next question. So if we have transient, what is the steady state condition? A state or condition of a system or process that doesn't change in time. So what is happening? Say we have again one switch, one R, L and C. We have one R, L and C. The switch is in the closed condition, means switch is closed. What will happen? Say the current in this circuit is 5 amps. The current in this circuit is 5 amps. If the switch is closed, we will get the 5, as this is a series current, we will get the 5 amps current throughout. It is not changing in time. Remember one thing, just after switching, switching means switch off or switch on. Just after switching means I0 plus or I0 minus, switch is off or switch is closed, we will get the transient response. But if the time tends to infinity, means for after a long time it will be in a fixed condition. Say the switch is closed. Again I am giving one more example. I am taking the another color so that you can understand. Say the switch is closed for an RLC circuit. For an RLC circuit, the switch is closed. Now, after 10 seconds, I have opened the circuit. So, input change. What will happen? While I am switching off, so there will be a transient condition. So, what will happen when previously switch is closed, means switch is on, current is flowing, we got a constant current. Suddenly I came and I switched off. What will happen? If you see it, so what will happen? It will show a transient. It will show a transient like this. And after 10 seconds, 15 seconds, it will totally off. So this is our transient condition and this is our steady state condition. So one system output has two parts. First one is the transient part, another one is the steady state part. At the moment of switching or at the giving of any input or external disturbance, we are getting transient. When it is for a long time, we are getting a steady state condition. What is the meaning of the initial condition? Before we solve the transient problems involving in inductors and capacitors, we must understand the initial condition that apply to the differential equation. What is that? I am giving one simple example. Say you have a capacitor. Now what is the meaning of the capacitor? What is the word? Capacitor will help to keep the charge. We know capacitor is equal to Q by V. So one capacitor is connected to a voltage source. One capacitor is connected to a voltage source. Now what will happen? So it will be charged. Capacitor will be charged with a Q charge. Okay, the capacitor will be charged. Now, suddenly we will disconnect the capacitor. So the capacitor will start to discharge. But it will not fully discharge any time. What will happen? Some charge will always present in the circuit. So this is called the initial condition. So if we want to write the voltage equation, we know that in the capacitor current is equal to C dV by dt. we know the current is C dV by dt. So what is the current? Current is C into dV is equal to I into dt, and we have to integration both side. Now while we are integrating this both side, it will not always starts from 0 due to the initial charge, due to the, or I means dq by dt. So we can write dq by dt into dt. So dt cancel out. So while we are integrating this q, the charge in the capacitor will never starts from 0. It will have always some initial condition. So this initial condition, this is the charge. We are taking one more example. Say we have one, this is an example of an inductor. We have a solenoid. What is the meaning of solenoid? One rectangular slab or cuboid slab of an iron. Say we have a slab of iron like this, and we are giving the connection to this. We are connecting it with the voltage source. So this is called the solenoid. So what is solenoid? One rectangular shape of this magnetic material on which we are keeping the coils. Okay. Now we are giving the current here. What will happen? This is the made of iron. So iron has two poles, north pole and south pole. In the normal condition, this north pole and south poles are not in a proper alignment. It will be always in the different alignment. That's why when there is a normal piece of iron, it is a non-magnetic thing. Now we are giving the connection. So what will happen? It is the positive and negative. So according to this all the atoms will align themselves. All the atoms will align themselves in north pole and south pole. Now we again disconnect the circuit. Next case, we are disconnecting the circuit. While we are disconnecting the circuit, what will happen? The magnetic property of this solenoid will never be 0. It has immediately some property will be always present. Next time when we will connect it again with the voltage source or with any battery, there will be some initial magnetization will be present. So this is called the initial condition. So what are the initial condition of an inductor? As I told, the initial condition of an inductor is I0 minus, that is the initial current which is always present, 0 minus. If 0 means the switching time, 0 minus means before switching, 0 plus means just after switching. There will be some initial condition. So for an inductor, I0 minus is equal to I0 plus, where it is assumed that a switch has been opened or closed at the network time t is equal to 0. The condition will be two types. What are the condition? At initial condition, the switch is closed. The switch is closed, current is flowing. Suddenly we opened the switch. Suddenly we opened the switch. So just before, not long time before, just before the switch is open, so I0 minus, and just after the switch is open, both will be equal, and this is the initial condition we will think as the I0. So what is the physical significance of this? We know voltage across an inductor is equal to L di by dt. We have discussed in the previous section also. V is equal to L di by dt. So V into dt is equal to L into di. If we integrate both sides, the current will not with 0. It will start from I0 to I final. T is equal to 0 to T. So while we are integrating this, similar things, say first condition switch is off, second condition, switch is on. So this condition also we are getting the initial condition. So for an inductor, I0 minus is equal to I0 plus, where it is assumed that a switch has been opened or closed in the network at t equals to 0. We are moving to the next question. What are the initial conditions of the capacitor? Already I have discussed initial condition for the capacitor. V0 minus is equal to V0 plus, where it is assumed that the switch has been opened or closed at the time in the network at t is equal to 0. What is time constant? Time constant is a very important thing in the view of an electrical engineer. What is the time constant? The meaning of the time constant is the time taken by the capacitor to be charged or discharged to about 63.2% of its full value through a resistor connected in the series, and this is we are telling for an RC circuit. This we are telling for an RC circuit. So if we want to plot the graph of the RC circuit, when a capacitor, when on RC capacitor we are connecting with a voltage source, we are getting the equation Ri plus, or we can write like this, I is equal to V by R plus C dV by dt. Or we can write V is equal to IR plus 1 by C integrating of I dt. So if we want to plot, we can see if the input is an AC, the capacitor will start to charge, and after second moment it will start to discharge. So first it will charge exponentially, then it will discharge exponentially. And what is the meaning of the time constant? As this is the final value, at the final value it is in the saturation level, not in the final value. It is become saturated if we increase the current, and it is an exponential curve, so it is not increasing infinitely, it becomes saturated. So for that we are taking the time taken to get the value at 60. If it is 1, so it is 0.632 volt. So time taken to reach 63.2% of its full value through a resistor, or time taken to discharge, time taken to the discharge of 63.2% value, we can call it as the time constant. Similarly, if we are taking for an RL circuit, then also we are getting the same thing, the time taken to charge up an inductor at 63.2%. So what is the formula of the time constant of an RL circuit? So the time constant for a series RL circuit is L by R. L by R. We can show it in a simple way. Say we have a RL circuit. We are giving the voltage. So what is the equation of this? V is equal to IR plus L di by dt. This is the equation of this. So what is the if we are taking it as a Laplace from both sides, we can write Vs is equal to Is into R plus L S di by ds means S into Is. We are just thinking the initial condition is equal to 0. We can take the initial condition also, but for time being we can show the initial condition is 0. So if we are taking the Is, so it is coming R plus SL. Vs is equal to R plus SL. So what is this meaning? Vs So Is by Vs, if we are checking this, Is by Vs is equal to 1 by R plus SL. Or we can write, if the input is unit step means or unit impulse, say the input is 1. So what is the value of the current? Is. Say the voltage is the unit impulse. Unit impulse means a very big voltage for a very small time. So what is the value? Value is 1. So what is Is? 1 by L S by R by L. So it is coming. So what is current? Current value is IT is equal to 1 by L e to the power minus RL by T. Or we can write e to the power minus T by tau. So what is tau? Tau is nothing but the time constant, time taken. So what is 1 by tau? 1 by tau is equal to R by L. So time constant is equal to L by R. So what is the time constant? Time taken to reach. If we put that T is equal to tau e to the power minus 1. So this means the time taken to reach the current is at the 63.2%. So what is the formula for the time constant of an RC circuit? That in the series RC circuit, the time constant is equal to the total resistance in ohm multiplied by the total capacitance in farad. So what is the time constant tau? Resistance in ohm and multiplied with the total capacitance in farad. Tau is equal to RC. So similarly, we can also show this one also, R and C. So what is the equation we got? We got that the V is equal to I into R plus 1 by C I dt. Because voltage across the capacitor is equal to C into dV dt is equal to I. So what is the value of voltage across the capacitor? 1 by C I dt. So what is, if we take the Laplace both side again, Is into Rs, this is integration, so 1 by Cs and Is. Again remember one thing, we are thinking that the initial condition is equal to 0. So what is Is? Is Rs plus 1 by Cs, or I am writing R only for simplicity, R plus 1 plus Cs is equal to Vs. So Is equal to Vs R plus 1 by Cs, or we can write Vs RCs plus 1 into Cs. So if we again do this, again we are taking it 1 and we are doing the Laplace inverse, we will get the equation V by R e to the power minus RC into T. 1 by RC into T. So what is tau? Tau is nothing but the R into C. So this is the time constant of an RC circuit. Now we are going to a very easy and small problem. A coil which has inductance of 40 millihenry and resistance of 2 ohm is connected together to form a LR series circuit. If they are connected with 20 volt DC supply, find the final steady state current. Remember one thing, the inductance, if it is an inductance, what is the value of inductance? Inductance value is always, or XL, the first we will write how to calculate the current. Current is equal to V by Z. As this is an AC circuit, we will not write the, as this is an R and C, both are, R and L both are present, we will write I is equal to V by Z. So what is V? V is equal to R plus JXL. What is XL? XL is nothing but the omega L 2 pi FL. Now one important thing you have to know. What is the type of the supply? This is the DC supply. DC supply means frequency is equal to 0. We know DC supply means frequency is equal to 0. When we are calculating the steady state value, what is the meaning of the steady state value? After a long time of switching, not in the time of switching. In the time of the switching, there is a change in input, so there should be some frequency. But after a long time, as the input is DC, so frequency is equal to 0. So what does it mean? The frequency is equal to 0 means XL is equal to 0 for the steady state condition or time tends to infinity or after 5 minute, 10 minute, 20 minute time. So what is the steady state value? V by R. What is the value of V? 20 volt. What is the value of R? 2. So current is 10 amps. What will be the time constant of the RL series circuit? So what I know, that time constant tau is equal to L by R. What is the value of L? 40 millihenry. What is the value of R? 2. So the value is 20 millisecond. We got the value 20 millisecond. As this is a time constant, the unit should be in the millisecond. What will be the value of induced EMF after 10 millisecond? What will be the value of induced EMF? So EMF induced is equal to, we know, it will be V into minus L by or T by tau. I am writing the simple equation first, T by tau. So what is the value of V? 20 exponential of T. What is the value of T after 10 millisecond? And what is the value of tau? We got 20 millisecond. So if we calculate it, we will get the value of the EMF and the unit will be in the volt. What is an overdamped response? Overdamped response means, we told at the starting we will get the transient condition. Now the transient condition we can differentiate in different parts: undamped, overdamped, critically damped, and underdamped. So what is overdamped system? The response that doesn't oscillate about the steady state value but takes longer time to reach the steady state than the critically damped case. So this is called the overdamped system. What is an overdamped system? Say we have a voltage 220 volt and we are starting on capacitor. We are charging a capacitor to reach the value. Now damping means the disturbance is so much that it will try to reach the 220 volt, but it will not reaching the 220 volt. It is going and going. This is called the overdamped case. It is trying to reach the steady state value but takes longer time to reach the steady state value than critically damped case. Critically damped case means exact case I want at, say, for according to our problem, in the 100 second it will reach the 220 volt, but due to this disturbance it is reaching at the 250 second. So what is this condition? This condition is known as the overdamped case. So in the overdamped case, the damping ratio zeta is equal to greater than 1. So zeta is equals to greater than 1. Next, what is underdamped case? Underdamped case means one that oscillates within a decaying envelope. Say we have a pendulum. Normal condition, if the pendulum is moving, there is no friction of air or no disturbance of here it will show one simple harmonic motion. Simple harmonic motion means nothing but the sinusoidal output. But due to this problem, it is going up, then down, then up, then down, then up, and ultimately it will stop. So this is called the underdamped system, and for the underdamped system, zeta is less than -1. It is coming to the steady state condition, but after some change. In our daily life system, 95% of the systems are the underdamped system. Next, we are moving to the term of damping ratio. The damping ratio is a parameter denoted by zeta. So, it can vary from undamped, underdamped, critically damped and overdamped system. So, if we want to draw, I will show you what is the meaning of undamped. If there is no damping, no disturbance is present in the system. So, what will happen? It will show a simple harmonic motion. Any system will show the simple harmonic motion. So, this is called the undamped system. Undamped system. And what is the undamped system? Zeta is equal to 0. Next, we are going to the critically damped system. Say we want the value here. This is our desired value. Undamped means it is reaching the desired value, but it is damping within a positive peak and negative peak. Undamped, critically damped means it will take some time, but it will reach very quickly. So this is called the critically damped system. Critically damped system means it will reach the desired value, and here the zeta value is equal to 1. Now we will discuss the other two. One is the underdamped system. One is the overdamped system. Overdamped system means it will reach the value, but it will take much more time than the critically damped system. So zeta is greater than 1. So it will reach our desired value, but it will take 1 more time. So this is called the overdamped system. And the last one is the underdamped. What is underdamped system? So this is our output. So first I am drawing with this color. So it will start, it will go, and after some times it will reach our desired value. So first it will oscillate with respect to the steady state value. It will oscillate with respect to the steady state value, and slowly it will reach our desired value. So this is zeta is less than 1, and this is called the underdamped. Underdamped. So what are the four? Critically damped, zeta is equal to 1. Undamped, zeta is equal to 0. Overdamped, zeta is greater than 1, and zeta is less than 1 is known as the underdamped system. Now we are moving to the question number 15. So what is an undamped system? As we discussed, when the damping ratio is equals to 0, which is showing an undamped response with consisting the continuous oscillation. What is the example? SHM, simple harmonic motion. Simple harmonic motion of a pendulum. Next, define the Laplace transform of function ft and state the properties of the Laplace transform. So what is Laplace transform? Laplace transform is nothing but a mathematical tool of a function of ft. We can write it as the L of ft, or we can write it fs. The Laplace transform helps to solve the differential equation, where it reduces the differential equation into an algebraic form. So Fs is equal to 0 to plus infinity ft into e to the power minus st. So what is the Laplace transform? Say we have an equation of the d square x plus dt square plus 5 dx dt plus 8 equals to 0. We can very easily solve it. If it is d to the power 4x dt square, then it is very tough to solve this type of equation. So in that case, we are using the Laplace transform. What are the properties of Laplace transform? I have taken it from Byju's. So first one is the linearity property, frequency shifting property, integration property, multiplication by time, complex shift property, time reversal property, and time scaling property. Details we have discussed in my lecture on the Laplace transform. Please check it once. Explain the characteristics of unit step function. What is unit step function? Unit step function means like a DC, it is as a unit step, the magnitude is 1, but for t is equal to 0. So unit step function we write by ut. Ut is equal to 1 for t is greater than equal to 0. When t is greater than equal to 0, this is amplitude. It is 1, but ut is equal to 0 for others. What is the value of that Laplace transform of ut? What is the value of the Laplace transform of ut? The Laplace transform of ut is 1 by s. So this is called the unit step. We can also tell it as the DC input or constant input. What is an unit ramp input? Unit ramp input means, as the ramp suggests, the ramp. Ramp means continuously changing. So ut is equal to t for t is greater than equal to 0, and ut is equal to 1 and is equal to 0 for others. What is the Laplace? Us is equal to 1 by s square. It is also known as the constant velocity function. It is also known as the constant velocity function. If we are going for a parabolic, what will happen? The function is equal to ft is equal to t square for t is greater than equal to 0 for others. So what will be the value? The value will be 2 by s cube for us. What is the unit impulse? Unit impulse we know, one big force for a small time. Say Rohit Sharma is playing the ball and suddenly he hits a 6. So what will happen? A big force for a small time. This is called an unit impulse. So if we want to draw the unit impulse, how we will get the unit impulse? Unit impulse we will get one big for a moment and other values are 0. So what is the value? Ft is equal to delta t. Function is a very big value for t is equal to 1 instant. Otherwise 0. Otherwise. And what is the value of Fs? Fs is equal to 1 for an unit impulse function. Calculate the time constant of a simple RL circuit. This is also very easy. What is the time constant tau? L by R. What is the value of L? 10 into 10 to the power minus 6. What is the value of R? 10 into 10 to the power 6. So it will be 10 to the power minus 6 by minus 6, 10 to the power minus 12 second. State the final value theorem. The final value theorem of the Laplace transforms enables us to find the final value of a function xt at t tends to infinity. When t tends to infinity, what will be the function value? Directly from its Laplace transform excess without no need of changing the Laplace domain into the time domain. We are directly using the final value theorem. We can inverse it. What is the formula of the final value? Say limit t tends to infinity. If t means we are calculating the any function value at t tends to infinity is equal to limit s tends to 0 s of fs, where ft Laplace of ft is equal to fs. If Laplace of ft is equal to fs, then we can write limit t tends to infinity fs is equal to limit s tends to 0 s into fs. So this is the final value theorem. Determine the xt and verify the final value theorem of this value. So we have given xs in this problem. So xs is equal to given 1 by s plus 3. We have to calculate the xt. Xt means Laplace inverse of 1 by s plus 3. What is the value of 1 by s plus a Laplace inverse? E to the power minus at. We are using the same formula. So Laplace inverse means e to the power minus 3t. Now we have to verify the function for final value. Final value, what it tells? Limit t tends to infinity xt. So what is the value of this LHS? LHS. Left hand side e to the power minus infinity, so the value is 0. Now we are calculating the RHS. RHS is telling limit s tends to 0 s of fs. So what is the value? S of fs 1 by s plus 3, or we can write s by s 1 by 1 plus 3 by s. Now as it is the limit, so s and s will cancel each other. 3 by 0 is equal to 3 by s is equal to 0, infinity. 1 plus infinity means infinity, and 1 by infinity is equal to 0. So both answer will be verified. LHS is equal to RHS. What is the initial value? Similarly, if ft and fs is the Laplace transform pairs, that is the initial theorem will give limit t tends to 0 ft is equal to limit s tends to infinity s fs. So same like the final value. So if t tends to 0, so limit s tends to infinity s fs. Find the initial value of the transformed function. Ft is equal to 3 ut plus 2 cos t ut. What is the output? So ft is equal to 3 by s into 2 s square. Sorry, fs, I am writing the fs directly. S square plus 1. Because we know the Laplace of ut already we have discussed 1 by s, and Laplace of cos t is equal to Laplace of cos t is equal to 2s by s square plus 1. Now we are calculating the final value theorem. What is the final value theorem tells? Limit s tends to 0 s of fs. Limit s tends to 0 s of fs. So it is coming s 3 by s by 2s s square plus 1. So first part it is coming 3, s's cancel out, 2s square, I am taking s square constant, 1 by 1 plus s square. So s square will cancel out. So what will happen here? The value will come at 3. Sorry, this question I have missed. So it is the final value theorem. So we are doing the final value theorem. So in the final value theorem, we got the final value as the 3. So here we are changing, we are calculating the initial value theorem. Calculate the initial value of the transformed. Again we will start from the same. If S is equal to 1 by S, 2S by S square plus 1. So what is the final value tells? Limit S tends to infinity. S of, this is the initial value, S tends to infinity, SFS. So S into 1 by S plus 2S by S square plus 1. Same problem. So again SS, and this is 3 by T, so 3 by S, 3 by S. So we are getting 3 here, 2S square by S square plus 1, 3 plus 2S square by, we are taking S square constant, 1 by S square. S square will cancel out. So 1 by infinity means 0. 3 plus 2 is equal to 5. So the initial value of this theorem is also 5. We can show this one according to the limit t tends to 0 within the t domain also, time domain also, how t tends to 0. So we know what is ut. Ut value is the, for t greater than equal to 0, it is 1. So what is the value of 3 ut? 3 into 1 plus 2 cos t ut. What is the meaning of ut? Ut means it has only in the positive side, negative side it is 0. So what is the meaning of cos t ut? Why this ut is given? The ut is given because it has only positive side. So cos t, cos 0 means 1. So 3 plus 2 is equal to 5. So LHS and RHS is equal. We can show the final value also same. So cos of infinity is equal to 0 and it is coming only 3 because the unit step means the t up to infinity value will come 3. So in this chapter we discuss the definition and terminology of the different questions. So these are the textbooks which I follows in this to discuss this chapter, and thank you.
Like, share and subscribe. Hit the bell icon for more updates.